Assalamu alaikum and welcome to Mathematics with Shahab Yaqub. In today's lecture, we'll be focusing on the integration review, and this will be the first part of that integration review. And this is P1. Now, this is what's written in the syllabus. Let's just highlight some of the major things. Understand integration as the reverse process of differentiation, that is NT differentiation. Integrate ax plus b raised to power of n for any rational n except -1. This is one limitation. Together with constant, multiples, sums, and differences, this is all the basics that we have done. Solve problems involving evaluation of a constant of integration. That means find the equation of a curve. A point is given for which the gradient function is given as such. Evaluate definite integrals. You plug in the limit, you evaluate, including simple cases of improper integrals. Use definite integration. That means integration with limit to find the area of a region bounded by a curve and the line parallel to the axis, or between a curve and a line, or between two curves. A volume of revolution about one of the axes. So that is the basic thing that we have done. Now let's revise our concepts by solving different kind of questions. Now, first of all, we are focusing on equation of the curve. And one thing in the beginning that I should point out is that I'll be focusing more on setting up the question. And as far as this thing remains, that is the complete working. Well, in certain cases, I would do, but the main theme of this lecture is that set up the integrals and focus on the important pointers that will help you gain marks. And the last thing, that means where necessary, I'll solve whole question. If not necessary, I'll just solve it partially. So now over here, equation of a curve. The theme is that if dy by dx is given, I integrate it and I get equation of curve. How do I evaluate constant of integration? By plugging in value of x and y. Now over here, the question says a curve passes through the point 4 and -6. That means when x is 4, y is -6. And let me just correct the small thing over here. So x is 4 and y is -6, for which the gradient function dy by dx is referred to as the gradient function because it tells us the gradient of the tangent to the curve. So dy by dx is given as x raised to power of -12, -3. Find the equation of the curve. Now the process is y equals to integral of this gradient function. Whatever rules of integration are there, just apply it. So that is x raised to power of -12 plus 1 divided by -12 plus 1. Negative remains as it is. 3 after integration with respect to x becomes 3x plus a constant of integration c. So now this is the basics of integration. And another thing that I emphasize a lot is that, which naturally the examiner also does, that is show all necessary working. Do not skip any steps. Do not skip any steps. People ask me, what is the secret of getting an A or A star? So the secret of getting an A star or an A is that just follow this, just follow this. When you will show all the necessary working, when you have a clarity of vision, when you are very, very conceptually sound, why in the world will the examiner be deducting any marks? So conceptually sound, that is relevant, that is possible when you show all necessary working and vice versa. So first simplify. So this is x raised to power of half. Negative half plus 1 is half. Minus 3x plus c. Simplify it. So flipping division by half is multiplication by 2. So this is 2 root x minus 3x plus c equals to y. Now you are in a position to plug in these values. X is 4, y is minus 6. X is 4, y is negative 6. Negative 6 is 2 root 4 minus 3 into 4 plus c. That is 2 into 2 minus 12 plus c. 2 2s are 4. 4 minus 12 is negative 8 plus c is negative 6. Therefore, negative 6 plus 8 is equals to c. C comes out to be 2. Therefore, the equation of the curve is y is equals to 2 root x minus 3x plus 2. Let's double check. So there is the idea. C comes out to be 2, y is equals to, let me enlarge it, 2 root x minus 3x plus 2. So this is all good, all clear. That is the first basic question. The next question, that is about a question with limits. So now, first of all, write root x as x to the power half. Write 2 over root x as 2x minus half. It is necessary that you write in this format. Let me just double check one thing. Yes, the voice is open. All good, all clear. So now, first write properly. Now integrate. X raised to power of half plus 1, division by half plus 1. This is 2x minus half plus 1 minus half plus 1. And since this is a case of definite integral, that means integration with limits. There is no constant of integration. It cancels off. The lower limit is 1. The upper limit is 4. Again, first simplify. Over here, let me get the highlighter ready. Over here, half plus 1 is 3 over 2. Over here, negative half plus 1 is positive half. So division by 3 over 2 is multiplication by 2/3, and this is x raised to power of 3 over 2. And over here, this is 2 root x, and division by half is multiplication by 2. All good, all clear? So now let's just put a big bracket and 1 and 4. 4, when I raise it to power of 3 over 2, it can be done in 2 ways. 4 raised to power of half, raised to power of 3, 4 raised to power of 3, raised to power of half. This is 2 raised to power of 3, which is 8. This is 64. Square root of 64 is 8. So therefore, when I plug in the upper limit, that is 2/3. 4 raised to power of 3 over 2, already evaluated, plus 2 into 2 is 4 root 4. Minus 2/3, 1 raised to power of 3 over 2 minus 4 root 1. So this is 8. 8 into 2 is 16 over 3. 4 into 2 is 8. Minus 2/3 into 1 is 2/3. Minus, it's in the bracket, that is 4. So now let's play around this with this and this with this. That's how you will do it. So 8 minus minus 4 is 12. And 16 over 3 minus 2 over 3, that comes out to be 14 over 3. That is 12. And this is 3 4s are 12, 4 2/3. And 12 plus 4 is 16 2/3. No units, nothing like that. 16 2/3, that is 26 over 3. Hold for a second. Let me just double check one thing. 8 minus minus 4 is 12. 12 plus 3 4s are 4 2/3. Let me double check. 3 into 4 is 12. 12 plus 2 is 14. So is there a negative sign or something? Let me double check one thing. There is a positive sign. X raised to power of half plus 1 divided by half plus 1. Half plus 1 is 3 over 2. Division by 3 over 2 is multiplication by 2/3. Half plus 1 is 3 over 2. Perfect. 2 as it is. And root x is x minus half. Minus half plus 1 is half. Division by half is multiplication by 2. 2 into 2 is 4. This is x power half. That is root x. All good. When we plug in 4, 4 raised to power of 3 over 2 is 8. 8 into 2 is 16. 16 over 3. 4 into 2, this is 8. All good. 2/3 into 1 is 2/3. And there is a positive sign. I think I missed this one. There is a positive sign. So therefore, 8 plus 4 with a minus in between. So that was the error that I made. So 8 minus 4 is 4. 4 plus 4, 2/3. That is, I think, 8 2/3. 3 8s are 24. 24 plus 2, 26 over 3. So either this or this, I would prefer this method. So there was a small minus sign mistake on my behalf. So accept your mistakes and learn from it, acknowledge it, and next time don't repeat it. As simple as this. Now let's look at this question. Now this question says a curve with equation y is equals to fx passes through these points. One of this point is 0 and 2. The other point is 3 minus 1. It is given that f prime x, this is given, f prime x is this thing where k is a constant. Find the value of k. Now, what is so special in this question is that 2 points are given. First of all, we have f prime x, that is kx squared minus 2x. Therefore, the equation of the curve is integral of this, that is kx squared minus 2x. Don't forget to write dx. This is equals to kx cubed over 3 minus 2x squared over 2 plus a constant of integration c. That is fx. Now, how many constants do you see? We see a constant k, and then we see a constant c. So there are 2 constants. That is why 2 conditions are given. So let me just erase this color and let me plug in one by one. When x is 0, f of 0 is 2. So when x is 0, f of 0, that is the y value, that equals to 2. So let me plug this in. So therefore, 2 equals to k into 0 cubed over 3 minus 2 will cancel out. That is x squared, which is 0 squared plus c. So therefore, c comes out to be 2. So there was no need of a simultaneous equation. It just became easier. So fx is equals to kx cubed over 3 minus x squared plus 2. Now plug in the other condition. So the first condition was this that we plugged in. This is this, and then plugged in 0, and we found out what is c. Now the second condition that I'll plug in, that is this one. The second condition is this one, which is 3 and -1. So when x is 3, f of 3 is -1. That's the y value. So -1, that is k into 3 cubed. So let me make it smaller. That is 3 cubed over 3 minus 3 squared plus 2. So this is -1. 3 cubed is 27 over 3. That is 3 squared, which is 9k minus 9 plus 2. Take everything to the other side. So -1 minus 2 plus 9 equals to 9k. So 9 minus 3 is 6 is equals to 9k. Therefore, k is 6 over 9 or 2/3. So they're interested not in the equation, but the value of k. Let's double check. K comes out to be 2/3. Let's move ahead. Solving with differentiation and integration. So it's a mix of 2 things. Now, first of all, I would ask you to read the question also. Think about it, and then I'll proceed. So I'll just have a sip of water. It says the diagram shows, let me first read it for you. The diagram shows part of the curve. Y is equals to 1 over 16, 3x minus 1 whole square. So that is a curve. And it's a quadratic curve, as you can see. And it's part of it, the curve, the whole curve is over here. This is almost in the completed square form, which touches the x-axis at point P. So that means we can find the value of P touches the x-axis, y coordinate is 0. The point Q3, 4, the point Q3, 4 lies on the curve. And the tangent to the curve at Q crosses the x-axis at R. State the x coordinate of P, obvious. Showing all necessary working, find by calculation, not by drawing, the x coordinate of R, the area of the shaded region PQR. So 5, 6, 11 plus 1, 12 marks. That's a big question. Now, first of all, let me focus on the first part, that is part 1, that is state the x coordinate of P. So in order to find the x coordinate of P, the curve touches the x axis at point P, therefore y is equals to 0. So therefore 1 over 16 disappears because it's equaling to 0. 3x minus 1 whole square equals to 0. 3x minus 1 equals to 0. Therefore x is 1/3. That's the x coordinate of P. All good? Showing all the necessary working, find the x coordinate of R. For x coordinate of R, what do you need? This is the tangent that we are talking about. That means the coordinate of R, we need the x coordinate because the y coordinate is 0, is small r comma 0. The coordinate of Q is 3 comma 4. Let me differentiate. So second part, y is equals to 1 over 16, 3x minus 1 whole square. Dy by dx, 1 over 16 is a constant, remains as it is. 2 comes down, 3x minus 1 remains as it is. Power reduces by 1. Don't forget to multiply by derivative of bracket, which is 3. So 2 and 16, that is 8. So this is 3 over 8, 3x minus 1, that is the derivative. Now, if I plug in the coordinates of Q, Q is 3 comma 4. Q is 3 comma 4. That means when x is 3, dy by dx equals to 3 over 8. 3 into 3 minus 1. Now, sometimes they give us very nice numbers so that the cancellation becomes very easy. This is 3 over 8. 3 into 3 is 9. 9 minus 1 is 8. 8, 8 cancel. Therefore, this comes out to be 3. Therefore, gradient of tangent is dy by dx is 3, which makes sense because it has a positive slope. That means if I apply the formula between 3, 4 and R0, the gradient formula, that is change in y over change in x, it should equal to 3. So let me just draw a line over here. And let me write Q as 3 comma 4. Capital R is small r comma 0. Gradient is 3. So 4 minus 0 and 3 minus r equals to 3. Therefore, 4 is equals to 3 into 3 minus r. 4 is equals to 9 minus 3r. 4 minus 9 is negative, 5 is negative 3r. Therefore, r is 5 over 3 or 1 whole 2/3. That is the x coordinate of R. Let's double check before we move on. And I need to add a page. So first thing was this, that this x is equals to 1/3, which was very obvious. The first part, when y is equals to 0. And the second part is this, when y is 0, x is 5/3. That's all good. Now, let me just copy paste this thing. And let me add a page over here because I need to work out the last part of this particular question. There are many more questions to come. The area of the shaded region PQR. Now, this is integration. So what we do is that we have this tangent like this. And we have this thing that is like this. And what I can do is that I can find the area of this triangle. And think about it. From here, all the way till here, that is all this region, including this shaded region. So if I integrate P from the x coordinate of P, which I think is 1/3, and the x coordinate of Q, which is Q, if I integrate this thing, curve, I'll find this total area. From this, I'll subtract this triangle. So first of all, let me write this thing as Q prime, area of triangle PQRS. I think S would be better. So this is S. The coordinate is 3, comma 0. Coordinate of R is, I think, 5 over 3. That's right over here. So this is 5 over 3, comma 0. Area of triangle, I need the base. The base is 3 minus 5 over 3. 3 minus 5 over 3. 3 into 3 is 9. 9 minus 5 is 4 over 3. That is the base. The height of this triangle, for a second, the height of this triangle, that is the y coordinate, which is 4. So the area is half into 4 over 3 into 4. That is 2 ones are 2 twos are 2 fours are 8. That is 8 over 3 unit square. That is the area of the triangle. Area under the curve between the limits, this is 1 over 16. This is 3x minus 1 whole square dx between the limits 1/3 and 3. So this is 1/3 and this is 3. This is using chain rule of integration. For using chain rule of integration, what do we need? We need this thing inside to be linear. We need a power which could be anything except -1. So it's all good. So this is 1 over 16. And this is 3x minus 1. 2 plus 1 is 3. Division by 3. Division by the coefficient of x, which is also 3 between the limits 1/3 and 3. So 3 and 3 is 9. 9 into 16 is 9, 6 are 54, 144. So this is 1 over 144. And this is 3x minus 1 whole cube. And the limits are 1/3 and 3. So 1/3 and 3. Now let me evaluate. 3 into 1/3 minus 1 whole cube. This is 1 minus 1, which is 0 cube, which is 0. And if I plug in 3 into 3 minus 1 whole cube, 3 into 3 is 9. 9 minus 1 is 8. That is 8 cube. Now, how much is 8 cube? Let me grab my calculator. So that's 8 into 8 is 64. 64 into 8, that is 512. 8 cube is 512. So this is 1 over 144. When I plug in the upper limit, so let me just plug in the upper limit, that is 3. So I'm getting 512. And when I am plugging in the lower limit 1/3, I'm getting a 0. And there is a sign in the middle, minus sign. So 512 divided by 144, that comes out to be 3.555. This is 3. My bad. Why is it not changing? So this is 3.555 units square. Now the area of the triangle is 8 over 3. What is 8 divided by 3 in decimals? So 8 divided by 3, that is 2.667. So this is 2.3.555 minus 2.667. What is the difference? Minus 3.555. That comes out to be 0.888. So this is 0.888. That is the area of the shaded region, 0.889. So I think after rounding off, because there are many 8s over here, so 0.889, correct to 3 significant figures. That is the answer. So now over here, just acknowledge a bit that this is all good, all clear. So this question on the board, that is area between, that is the thing. Is this all good, all clear? So AS2, AS1, and this thing. So that is the thing over here. Okay. I think I'll skip this question. Okay, now this one looks like a nice question. Go through this particular question first. Let me just pause the recording. Now, let's look at this question. It says dy by dx is this thing. A is a positive constant. Let me start underlining from the beginning. The point A lies on the curve. Find in terms of A. That is what sometimes people find difficult. The equation of the tangent to the curve at A, simplifying your answer. The second part, the equation of the curve, and both are in terms of A. So let me first focus on this. And then maybe if there is a need, there is the next page. I think, yeah, I just need the next page for this. And then we'll be focusing on the next part. Now it says dy by dx is this thing. So first of all, part one, dy by dx is equals to 2 over a. A is a constant, x raised to power of negative half, ax negative 3 over 2. This is what I was talking about in class today, that sometimes indices, it annoys you a lot because there is a lot of indices that is in process. Now, first of all, if I talk about equation of tangent, that means the point is this thing, which is a squared comma 3, capital A, small a squared comma 3. Now, equation of tangent, I need to plug in when x is a square dy by dx. That is 2 over a square raised to power of negative half. And this is a square raised to power of negative 3 over 2. All good? Now, the rule of indices that you need is that a power m raised to power of n, that is a mn, the powers multiply. So over here, if I focus on this, so this power 2 will multiply with negative half. This power 2 will multiply with negative 3 over 2. So let's first simply multiply. So this is 2 over a. This is a raised to power of negative 1. This is a on the outside, a square into this thing, a raised to power of negative 3. So far, so good. So now write this thing as 2 over a, 1 over a. This is a raised to power of 1, a raised to power of negative 3. That's a raised to power of negative 2. I can further write this thing as 2 over a square plus 1 over a square. All good. And they are asking the equation of tangent, but first I'm working for the gradient. So this is 1 over a square. This is 2 plus 1, which is the same thing as 3 over a square. That is dy by dx, which is the gradient of the tangent. They're asking us equation of tangent, simplifying your answer. So let me add a page. Again, the coordinate of this point, capital A, which is a square comma 3. So A is a square comma 3. Apply the formula y minus y1 is equals to mx minus x1. Y minus 3 bracket equals to m, which is 3 over a square x minus a. And I think it's better that we use the other bracket, the curly bracket. So x minus a, the round bracket. Cross multiply. A square y minus 3a square, that is 3x minus this 3x over a square minus 3a over a square. And it depends on which is the format that you need. So I think I can leave it as it is. Let me just hold for a second. If I leave it as it is that the format that the examiner has given the answer in? Y minus 3 is this thing. I think this is pretty simplified. Let's double check. So now this is y is equals to 3x over a square. So they have simplified it a bit. Let me first double check. Y minus 3 is equals to 3 over a square. Our gradient is all good, all perfect. X minus a square. And then they have written in this format, and then they have simplified it a bit. So I think they want us to simplify. So what we can do is that if I open up the bracket, there is one thing I need to do. So first of all, if I cross multiply, so this is a squared y minus 3a squared. This is equals to 3x minus 3a. And then if I write a y square is equals to 3x minus 3a plus 3a squared. All good. So this is a square into y. This is a square into 3. And I think that this, if I divide by a, what happens? So y squared, there is a square, my bad. So let me just correct myself. So this is a square into y minus 3a squared. And this is 3x minus 3a. So therefore, a square y is equals to 3x minus 3a plus 3a square. And if I make y the subject, so that is 3x over a square. This is 3a over a square plus 3a square over a square. So we can simplify it a bit. So that is perfect. And even this much is good enough, because they are not asking us to make y the subject. It doesn't say so. Simplifying your answer. So this is also a simplified form. All good, all clear. So that is 3 over a squared. Now this thing is done. Let's move to the next part. So now we have the second part right in front of us. That is the equation of the curve. So now if I'm interested in equation of the curve, so now I need to integrate it. So second part, that is y is equals to 2 over a x raised to power of negative half plus a x raised to power of negative 3 over 2, put it inside a box, integral sign, and so on. So this is 2 over a x raised to power of negative half plus 1, negative half plus 1, a as it is, x raised to power of negative 3 over 2 plus 1, negative 3 over 2 plus 1, plus a constant of integration c. So this is 2 over a is a constant, division by half is multiplication by 2, and this is x raised to power of half, which is root x. This a remains as it is, negative 3 over 2 plus 1 is negative half, division by negative half is multiplication by negative 2, and this is x raised to power of negative half plus c. All good, all clear. So therefore, this is 4 over a root x. This is minus 2a over root x plus c. That is the equation of the curve. Now we have to plug in this thing when a is a square, when x is a square and y is 3. When x is a square, y is 3. So therefore, 3 is equals to 4 over a root a square, and this is minus 2a over root a square plus c. Let's simplify it a bit. 3, 4, a from here, 2a from here plus c. So it's good that the a's are canceling off. That is 4 minus 2 plus c. 4 minus 2 is 2. So c comes out to be 3 minus 2 is 1. So c comes out to be 1. Therefore, equation of curve y is equals to 4 over a root x. That is 4 over a root x. This is minus 2a over root x, minus 2a over root x, and the value of c is 1. Let's double check. So 4 root x over a. That is 4 root x over a minus 2a x raised to power of negative half. Minus 2a x raised to power of negative half is root x in the denominator. And the value of c is 1. So this is all good, all clear. So again, I need to copy this. And I need to move to next page so that I can try out the last part. Now it says it is now given that this thing b is 16, 8 also lies on the curve. Find the value of a, and using this value, find the distance AB. So 16, 8 also lies on the curve. So when x is 16, y is 8. The equation of the curve is y is equals to 4 root y is equals to 4 over a root x minus 2a over root x minus 2a over root x plus 1. If I plug this thing in, x goes over here, x goes over here, and this y goes over here. So this is 8 equals to, this is 4 over a root 16 minus 2a over root 16 plus 1. So let's simplify. This is 8. This is 4 over a into 4 minus 2a over 4 plus 1. So 8 minus 1 is 7. 16 over a. And this is this a is in the numerator minus a over 2. So let's take LCM over here or multiply by a first. So this is 7a. And this is 16 minus a square over 2. Let's multiply by 2. 14a, 32 minus a square. So a square minus plus 14a minus 32 equal to 0. No harm in double checking. A square plus 14a minus 32 equals to 0. All good. And it says a is a positive constant. So now middle term factorization. Let me put a line in the middle. So therefore, a square, that is a square, that is 16 into 2, minus 2a plus 16a minus 32 equals to 0, a common, a minus 2, plus 16 common, a minus 2 equals to 0, a minus 2, a plus 16 equals to 0, a is positive 2, a is negative 16. Except this because a is a positive constant. And over here, reject this because a is positive. All good, all clear? Now when a is 2, what are we looking for? Find the distance AB. Now a is a square comma 3. So a is a square 2 square comma 3. And b is 16 comma 8. So therefore, the distance AB is equals to, this is 4, this is 16, 4 minus 16 whole square. This is 3 minus 8 whole square, square root. 4 minus 16 is 12, 12 square is 144. And this is 5 square, that is 25. 144 plus 20, 164, 169. This is square root of 169, therefore 13 units. So 13 units is the answer. That is the magnitude of this. So how was this question? A very elaborate question. Took us a lot of time to try this out. And it had all the parts. 5 and 4 is 9, 9 plus 3 is 12 marks. That's a lot of marks. Okay. Now, in this particular question, I'll be focusing on the setup. First, go through this question. Let me double check if everything is all good, all clear. Okay. I'll just focus on one thing. That is the second part in this one, because sometimes they come up with question like this. Now, when we use the concept Let me revise this thing. When we have this concept of area between two curves, so hold for a second, let me first get this thing ready. When we have this thing that there are two curves, I'm just writing in general form. Let's say one of them goes like this, the other one goes like this, and let me mark this as y, let me mark this as x. These are the two common points. Let me just grab these two and just shift it over here. It doesn't make a difference where it goes. So now over here, this is one common point, that is A. This is another common point, that is B. And the shaded region is in the middle. So let me just shade this region over here. That is the shaded region. So now this shaded region is the area between the two curves. So now there are two ways of doing it. This is the shaded region. So let's say the red one is y is equals to fx. That is the equation at the top. And the purple one is y is equals to gx. That is the equation at the bottom. So this is the top curve. This is the bottom curve. And basically, this is what we do. Area under the red line, the red curve, that is the limits a to b, fx dx. Area under the purple curve, that is again a to b, gx dx. And the area in between the two, that is area of red minus area of purple. That is top minus bottom because the top has more area. All good, all clear? So that is the logic that we apply. Can I write this thing as area between, that is the limit a and b, fx minus gx? Yes, I can. The reason being that the two limits are the same. The two limits are the same. That is why I can do this. Now, keeping this concept in mind, let's read this question. The question says, the diagram shows part of the curve, y is equals to such and such. So this is one curve. That is, the top one is the red line. And the bottom one is the purple one that goes like this. Got the idea? And the region between the two, that is this green region, if I'm just drawing a parallel to the previous example, that is this green region right over here. All good? That means area under the top curve, that is whatever the limits are, and this is, it's under the line 1 minus 2x dx. Area under the bottom curve, that is the purple one, that is again this equation 1 minus 2x minus 1 minus 2x, the whole thing cube in bracket dx. What are the common limits? The common limits are this, that is 0, and this is a, which is half. So this is 0, this is half, this is 0, this is half. I'm focusing only on this part. Show that the area of the shaded region bounded. So the area of the shaded region can be expressed as this and this. So area of top minus area of bottom. So area between, that is 0 till half. This thing minus this thing inside a bracket dx. In the first one, I'll write the red color. That is 1 minus 2x. In the next one, I'll write the purple color, 1 minus 2x minus 1 minus 2x cube. Got the idea? Double check. That is the area at the top. That is under this line. This is the area under the bottom curve. That's this weird equation. So when I do the subtraction, what disappears? This thing over here 1 minus 2x, 1 minus 2x, this cancels off because of the negative sign. And because of the negative, this negative will make this positive. So therefore, this is coming out to be between 0 and half. This is 1 minus 2x whole cube dx. So you don't have to do extra working. You can just simplify it. And that is the answer for this part. The rest of the working is simple. That is integration. So just acknowledge this simple thing. That is this, which is the idea that is between simplified. Is this all good, all clear? Between and simplified version, is this all good, all clear? Okay. Okay, let's go back and maybe there is a small slip in one of the question. Let me just double check. That is this question. Someone pointed it out because I did not simplify it. Okay, I think in this one, it needs to be simplified. The coordinate was a squared comma 3. So that means when x is a, it's not a square, y is equals to 3. So it's a good idea to write it because I think I slipped this thing out. So now if I simplify, it will even become shorter. Okay. So now if I open up the bracket with a square or just on the right hand side, y minus 3, that is 3x over a square, and this a square cancel will give me 3. And then this 3 over here cancels with this 3. Therefore, y is equals to 3x over a square. That is the simplified form. So there was a small slip of this a square, which was not inserted here properly. So someone pointed it out and I got it all correct. So that is the kind of question that comes. Again, have a look at this particular question. Just go through this particular question. So now it says the diagram shows part of the curve. That is part of the curve that is going like this. And a point P, 2, 1 lying on the curve. P is 2, 1 lying on the curve. The normal to the curve at P, because the tangent would be like this. So this is the normal. So the normal, let me draw it. The normal to the curve at P crosses the x-axis, intersects the x-axis at Q, show that the x-coordinate of Q is 16 over 9, and then find, showing all necessary working, the area of the shaded region. So nothing special in this one, except for the fact that you have to drop a perpendicular and you have to focus on this triangle like this. And if Q is 16 over 9, let me just draw it on the sidelines. So this goes like this. And let me draw this vertical line like this. So a little bit exaggerated is needed over here. Now, this is 16 over 9. Let me first focus on it. This is 16 over 9. This is 2. So the difference, the base is 2 minus 16 over 9. 9 2s are 18. 18 minus 16 is 2. That is 2 over 9. So the base is 2 over 9. And the height is 1 unit. The height is 1 unit. So the area of this triangle, that is half into 2 over 9 into 1. This comes out to be 1 over 9 square units. Now, first of all, how will you find that the x coordinate of Q is 16 over 9? That is by differentiation. Y is equals to 3, 1 plus 4x raised to power of negative half. Dy by dx is equals to 3 as it is. Negative half comes down. 1 plus 4x, negative half, negative 1, negative 3 over 2. Derivative of bracket is 4. Now cancel this 2 with this 4. This 2 cancels and 2 remains. So this is 3 into negative 1 into 2. That is negative 6. And this is 1 plus 4x raised to power of 3 over 2. When we plug in x is equals to 2, that is the x coordinate. When x is 2, this is at point P. So dy by dx is equals to negative 6. 1 plus 4 into 2 raised to power of 3 over 2. That is negative 6 over 9 raised to power of 3 over 2. Again, indices. 9 raised to power of 3 over 2 can be written as 9 raised to power of 3 raised to power of half. 9 raised to power of half raised to power of 3. So it's simpler to evaluate. Square root of 9 is 3. 3 cubed is 27. So therefore, this is negative 6 over 27, which can be written as 2 and 9, negative 2 over 9. That is dy by dx. Gradient of tangent is negative 2 over 9. Gradient of normal should be negative reciprocal. So the negative will become positive, 9 over 2. Point P is 2 comma 1. And point Q is small q comma 0. So the gradient should be equal to 9 over 2. 1 minus 0, 2 minus q is 9 over 2. Therefore, 2 is equals to 9 2s are 18 minus 9q. 2 minus 18 is negative 16 is negative 9q. Therefore, 16 over 9 is q. And that is what you were proving. So the first part is all good, all done and dusted. Find the area of the shaded region. Let me just solve this thing completely. No, I don't want to cut it. Just want to copy it. And let me add a page. So now the second part, the area. For that, first integrate between the limits. This is 0. That's right over here. And this is 2. And we already found the area of the triangle. So therefore, area under the graph, under the curve, that is between the limit 0, 2, 3 is there. 1 plus 4x raised to power of half dx. 3 as it is, integrate 1 plus 4x, half plus 1 is 3 over 2. Division by 3 over 2. Derivative of bracket is 4. Between the limits 0 and 2. So this is 2 1s are, 2 2s are, and 2 into 3 is 6. 3 over 6 is half. That is half. This is 1 plus 4x raised to power of 3 over 2 between the limits 0 and 2. If I plug in 2, therefore this is 1 plus 4 into 2, 8. 8 plus 1 is 9. 9 raised to power of 3 over 2. We just evaluated 27. If I plug in 0, so this is 1 raised to power of 3 over 2. There is a negative sign in the middle. And there is this half over here. So half over here, 27 minus 1 is 26. 26 divided by 2 is 13 units square. And the area of the triangle is 1 over 9. So 13 minus 1 over 9, that is 12, 8 over 9 square units. That is the answer. No harm in double checking. That is 9 2s are 18, 18 plus 8. Okay. I think one small mistake of this area. This is 9 raised to power of 3 over 2 is 27. Half plus 1 is 3 over 2. Let me just double check over here. Yes, it's 3 over 2 in the denominator. And this is half is there. This is 27 minus 1 is 26 divided by 2 is 13. I think some small mistake is there. Let me just double check. 3, oh, this is negative half. My bad. This is negative half. So let me just do this thing again. It's not positive half. So that is a small mistake that you have to pay for. And yeah. Okay. So now over here, black marker, this is 3. This is 1 plus 4x raised to power of negative half plus 1. This is negative half plus 1. 4 comes out here. Between limit 0 and 2, this is 3. Negative half plus 1 is half. Half into 2 is half into 4 is 2. So 2 is in the denominator. And this is 1 plus 4x square root between the limit 0 and 2. So this is 3 over 2. 8 plus 1 is 9, square root of 9 minus square root of 1. So that is 3 minus 1 is 2. So this comes out to be 3 units square. That was also coming out beautiful, but I mean, it was wrong because I took the wrong power. So therefore, over here, I need to erase this thing. So therefore, 3 minus 1 over 9, that is 2, 8 over 9 square units. And that is the answer for this particular part. So I think that's a lot of work for today. We did a lot of questions about getting equation of curve. We talked about something with limits. We talked about area under graph, different kind of scenarios with a lot of indices involvement. And that is the integration review part 1. Stay tuned for part 2, which will be uploaded tomorrow. Take care, everyone.